Okay, in the last video, we have talked about the general basic 4 steps to hypothesis testing. Since this handout is about the hypothesis test for population mean, so let's specify in more details about those 4 steps when you're trying to do a hypothesis test for population mean. So the first step is to establish the null and alternative hypothesis. So the null hypothesis will be your true population mean mu equals to a specific value mu null. This mu null is a placeholder. This is not something new. It's just when you see a real question with real context and real number, you will replace this mu null with the number you see in the question. I just put it here as a placeholder for the null value, which is a specific mean of interest. In our example of the caffeine example, that's the 60. So that's our null hypothesis. Remember we mentioned that the null hypothesis is always with the equal sign. The choice of alternative hypothesis, there are 3 choices. So it could be mu greater than the mu null, the mu less than the mu null, the mu not equal to mu null. So the first 2 is called one-sided test. The last choice is called two-sided test. Two-sided test. So the one with the not equal sign is called the two-sided test. The rest 2 are called one-sided test. And when you construct your alternative hypothesis, you will just choose one of those 3 based on the context of the question. So that's the first step, establish null and alternative hypothesis. The next step, step 2, check conditions and calculate the test statistic. There are 2 conditions. First, it has to be a random sample. Second is the is your population follows the normal distribution. But the second condition is okay if you violate it a little bit, because the test itself is a robust test, which means even though you violate this assumption a little bit, that's okay. It's the test result. It's not going to be too bad. That's what that means by robust. This is especially when your N is large enough. Remember our rule of thumb is 30, and again, how large is large enough depends on what's your population distribution actually looks like, but the rule of thumb is 30. So if you satisfy those 2 conditions, then you could calculate your test statistic like this. Remember, we introduced the general form of test statistic is the statistic minus the null value divided by the null standard error, right? So that is the statistic y bar minus the mu null divided by s over square root of m. If you construct your test statistic like this, then this will follow a t-distribution. How we know it follows a t-distribution is either by simulation or by theoretical deduction. We are not, I'm sorry, the theoretical derivation. We are not going to talk about how we get it, but you just need to know that this is going to be a t-test statistic. So identify the null distribution, find the p-value, and make decision. The null distribution is under the above conditions. If those two conditions are met, this test statistic will follow a t-distribution with degrees of freedom equals to m minus 1. So that is, again, the sampling distribution, the test statistic is following is called the null distribution. Then we could find the p-value as the probability under H null, but in the direction of HA. We will talk in more details about how to find this p-value later on. I just listed here as a step. We will talk more detail about how to find the p-value. Then we apply the decision rule of thumb. If p-value is less than alpha, we reject H null. Well, if we reject H null, we say our results are said to be statistically significant. Then we need to make a conclusion in the context of HA. So if we reject H null, we say there was statistically enough evidence to support HA. If we did not reject HA, when is the case we do not reject we do not reject H null? That is when our p-value is greater than alpha, right? So when our p-value is greater than alpha, we do not reject H null. And we say the conclusion is there was not enough evidence to support HA. Please be careful at what I have just said here to make the conclusion about did not reject H null. I'm not saying we prove H null is wrong. We are saying there was not enough evidence to support H null. I'm sorry, HA. There was not enough evidence to say your alternative hypothesis is right. So you have to be really careful about this interpretation here when you're trying to make the conclusion, because this is just a hypothesis test. We are not proving anything or not proving anything. We are just trying to provide enough evidence, or we are not able to provide enough evidence based on the data we got. We could make some errors here. We are going to talk about the errors that we could make in hypothesis test. So in order to stay away from any trouble that you may encounter, you don't want to get yourself into trouble, right? If you are saying something, you have to be responsible for it. You don't want to say something and then later on somebody prove you are wrong. So it is possible for us to make errors when we make those conclusions or reject or not reject H now. So we are not saying we prove H now or we prove HA. We are saying if we reject H now, we are saying there was statistically enough evidence from the data we collected to support HA. If we couldn't reject H now, we are saying there was not enough evidence from the data we collected to support HA. Okay, this is the end of the content materials that I was planning to cover for the lecture on March 28th, Saturday. Okay.